Okay, so we're going to take a look at an example about what kind of conclusions we can make depending on how the study was designed. Here's the basic rule of thumb. So if we are having a random sample, like the subjects are randomly selected, then we can have that conclusion extend to the population. Okay, it could be a cause and effect, or it could be just a correlation between the two variables. The cause and effect piece depends on whether or not the subjects were randomly assigned to treatment groups. Okay, so that's the deal. If we have treatments that we are randomly assigning to our subjects, that's an experiment, we can then make a cause and effect conclusion. This chart here kind of gives you the yes with random assigned groups and yes with random selection. Or yeah, that's top part is the treatments part. The side is the sample part. Yes, yes, you can say inference to population and cause and effect. That's kind of that how to read that chart. Okay, so let's take a look at the example. I actually have that chart further down as well. So if you're looking at the notes further down, if this loads up, before we get into those, you can see how that plays out in this chart here. Okay, so that's down here as well, right? And this one, it's the treatments on this side and the sampling on that side, but that's the idea. If you don't want to use that chart, that's fine, right? It's okay to just kind of look at it in terms of, do we have a random sample? Then we can talk about the population with our conclusion. Do we have random assignment of treatments? Then we can say cause and effect. So we're going to look at these designs here. Okay, so we're looking at this example when we have a small town dentist wanting to know if the doses of vitamin C will result in fewer canker sores in people's mouths. And we're going to look at 4 different designs, right? 1, 2, 3, and 4, and then see with those designs what kind of conclusions we can make. All right. So design 1, let's start there, right? Read through, get all dental patients in town with appointments in the next 2 weeks to take part in a study. Okay. They're getting dental appointments in the next 2 weeks. Is that a random sample? Doesn't look like it. It's like a convenience sample. So we don't have a random sample here. So we've got that. The next part, give each patient a survey with 2 questions. Do you take at least 500 milligrams each day? Do you frequently have canker sores? Is that assigning the treatments or just observing what's already happening? Well, in this case, it's observing. So we, 1, don't have a random sample. It's just the patients in the next 2 weeks. And 2, we don't have treatments assigned. So we're just observing what they say. So that's a no and a no to those 2 options. And we can then go down and see what kind of conclusion we can have based on that, right? We can only say there could be a correlation depending on what they say in the answers, right? And we could only have that result be attributed to the people that took place in the survey. So no, no, there you have it. So read through that design. On the side here, I've identified that it's not a random sample, not a random assignment of treatments. So that's how you want to play this out. You want to look through these things and ask those 2 questions, judging by the design. Okay, so let's take a look at the design 2. It says, get all dental patients in town with appointments in the next 2 weeks to take part in the study. Randomly assign half of them to take the vitamin C and the other half to not, right? And then you can get the results there. So we have the same sample, meaning that the sample was not random. It was just the 2-week people. But we do have a random assignment of treatments, right? We randomly selected one group to get vitamin C and then the other group doesn't. So our result, if we scroll down, we'll notice in design 2 that our result here talks about the fact that we could say that, vitamin C has a cause and effect relationship to canker sores, but we still can only attribute that to the people that took place in the study because it was not a random thing. And that's the deal with design 2. Design 3, if we look at design 3, select random sample. Let's move up here a little bit. Sorry, that's kind of small print, but select the random sample of dental patients in town and get them to take part in the study. Divide the patients into 2 groups as in design 1. So if we go back to design 1, remember we're just basically asking them, right? So what is design 3? We say that it's yes, random sample, because we randomly selected from dental patients, but we didn't assign who was going to get vitamin C or not. So we can give the results to the population, to all dental, but we can't say that the vitamin C causes less canker sores. Now, design 4, we've got the random sample, right? It says select a random sample of dental patients, and we randomly assigned half of them to vitamin C and the other half to not. So we have both here. We have, yes, a random sample and a random assignment of treatment. So we can do it all. We can give the results to all dental patients, and we could say that vitamin C has a cause and effect relationship to canker sores because of having both randomized features. So that's what you want to answer first, right? When you read these questions, you want to answer in the design, is the subjects randomly selected? Yes or no? That talks about population. Then for our result, then ask, did we have a random assignment of treatments? Yes or no? That links into our cause and effect. And that's how it goes. So read through the results here, these solutions, so that you have a better sense of how they talk about it with their conclusion. What's in here is that first thing that we want to answer from the design to help us get to those conclusions.